All right, so 34. So it's projectile motion. A projectile is launched straight up from ground level with an initial velocity of 272 feet per second. So our S sub 0 is going to be equal to 0 because it says it starts at ground level. And the initial velocity, so the V sub 0 is given to be 272 feet per second. And so it wants to know, first of all, for part A, when the height above the ground is 960 feet exactly. So we want to know when that is. So that is going to be our S value here from our equation. So since we know S sub 0 is 0, I'm not even going to write that when I write down my equation. So S is equal to negative 16t squared plus V sub 0t. And so then plugging stuff in, I've got 960 is equal to negative 16t squared plus 272t. And so then moving this stuff over, I'm just subtracting 960 from that. Now, I would say always start out by checking to see if the negative 16 can be taken out, because a lot of times the book is nice and it can, and so it makes your life a lot easier. So all right, it does come out of 272. And it does come out of 960. So we would have negative 16 times t squared minus 17t plus 60. And so this 16 is going to go away. Because dividing it over here, 0 divided by negative 16, just 0, so that's gone. So then I need factors of 60 that give me negative 17.
Negative 5 and negative 12.
Negative 5 and negative 12. So that's going to be t minus 5 and t minus 12. We set that equal to 0. So we get t is equal to 5 or t is equal to 12. So again, that basically tells us, just for a reference, that essentially 960 feet is here, and so right here and right here, it's exactly 960 feet, and that would be at 5 seconds and 12 seconds is basically when that's happening. So I should put units on those. Following so far? All right. So then part B wants to know when it is basically higher than 960 feet. So without having to do anything, what do I know?
So it's at 960 feet at 5 seconds and 12 seconds. So our answer would be that it's between those two.
Yep.
Points.
And is it including or not including 5 and 12?
Not included.
Not including because it specifically says higher than. Okay, the example that we looked at in the book said at least, which includes it. This does not. So this is just going to be, whoops, wrong color. 5 to 12, not included. Then part C says, when will the projectile's height above the ground be less than or equal to 960 feet? So when is it less than or equal to 960? Okay, so under 5, but time can't go where? Negative, so it's got to be 0 to 5.
So we can't include 0?
No, because you can't have 0 time for something to have been, like, launched.
Is that just the V next to it?
It's a union, so we're going to add something. So you said anything below 12, right? Well, I'm assuming you mean, like, below on this side.
Yeah.
Okay, so oftentimes we would write 12 to infinity. However, we know that it's going to eventually come back down to the ground, and it's going to be at ground level. So, what do we know about parabolas?
They're like the same on both sides.
They're the same on both sides. So if there's 5 seconds over here, what do we have to know about over here?
There's 5 seconds over there.
There's also 5 seconds over here. So this one is going to actually be 12 to 17. And because it's back at the ground, we don't include 17. Okay. Now, if on a test or a quiz or something you had happened to write, to infinity, I probably would just make a little note on your paper and be like, well, almost. Not
quite.
Can't go out to infinity time for it's not hit the ground again, but anyways.
So where'd the 17 come from?
So basically we knew that a parabola is symmetric, right? And so we knew that over here, this was 5 seconds, because basically from the launch point, this was at 0 seconds. So it took 5 seconds to get to that point. So we know that when it's coming down, when we get here, there's also got to be another 5 seconds to get to here.
Okay.
So that it's the same on both. It's kind of just like knowing things about parabolas, and that projectile motion is always parabolic.
So you just have to be smart.
It's not like in, the cartoons when you see, like, the Road Runner or something, like, walk off the edge of the cliff and he just, like,
Stands.
drops straight down. Like, actually what happens is he, it's parabolic in nature and how he comes off. You just don't see the launch of that, but it does the same thing. It's still a parabolic, just that side of it. All right, so did I give you problems yesterday? All right, so adding on to that, I'm just adding number 33, which is just like what we just did. It's just one for you to do by yourself to try.